So in this lesson, we're going to look at how to balance a redox reaction. And the easiest way, in my opinion, to balance redox reactions is by using the half reaction method. Now, what you want to do first is you want to separate the redox reaction into separate half reactions. So remember, there's an oxidation half reaction and a reduction half reaction. So you're going to separate the half reactions into two. Remember, two halves make a whole. You will have one that's an oxidation half reaction and one will be a reduction half reaction. Now there's several steps needed to balance a redox reaction, and in this lesson we're going to focus on how to balance the redox reaction if it is in a neutral or an acidic solution. First, you want to write your separate half reactions. There will be two half reactions. Again, one will be an oxidation half reaction and the other will be a reduction half reaction. Now for each half reaction, you're going to do a couple of things. The first thing you will do for each half reaction is you're going to balance all elements except for hydrogen and oxygen using coefficients. So you're going to look at your half reactions, and if there's any atoms other than hydrogens and oxygens, you're going to use coefficients as you would normally do with a balancing equation. Now here's where this balancing goes very different than a normal balancing equation. You're going to balance your oxygens using water molecules. You're going to balance your oxygens with water molecules. So at this point, you will have added some hydrogens. So the next step is to balance the hydrogens. And you balance hydrogens by using hydrogen ions. Not diatomic hydrogens and not just an atom of hydrogen, but you use the H+ ions. Next, you will balance the charge in the half reaction, and you balance the charge using electrons. So yes, we'll be adding electrons in these half reactions, but don't worry, before we add them back together, you're going to make sure the electrons all cancel out. But this is a necessary step in balancing a redox reaction. So balance your charge using electrons. Now, once you've done that, it may be necessary to multiply one or both of the half reactions by an integer to equalize the number of electrons transferred. You've got to make sure that the electrons cancel out. They must be equal before you add the half reactions back together. Next, you're going to add your half reactions together and you're going to cancel out the electrons. All of those have to cancel, and sometimes you will have hydrogen ions as well as waters that may cancel as well. And we will see that in our example, one of our examples we're going to do in just a minute. Then you want to check and make sure the elements and charges are balanced. That is just sort of a check to reassure you that you have done it correctly. If both your charge and your elements are balanced, then you know you have done the reaction properly and it is a correctly balanced redox reaction. Now for the examples we're going to do, I'm going to switch to my Elmo just so that I can make sure I can color code some of this more easily as we go through the examples. So for our first half reaction, we will be considering the redox reaction between the permanganate ion and the iron 2 ion. So we're going to separate the reaction into two half reactions. So it's usually pretty easy to pair them up because you're going to pick the things that are very similar, that have something in common, atoms in common on both sides. So I've kind of connected my two half reactions. So let's split up our redox reaction into our two half reactions because remember, we are using the half reaction method. So one of your half reactions is going to be MnO4 -1 yields Mn2 plus, and then Fe2 plus yields Fe3 plus. So now we have both reactions split into the half reactions. Now remember, for each half reaction, we have multiple things that we do. You might want to refer back to the notes we just copied down to help you, but here we go. All right, so balance everything except for hydrogens and oxygens with coefficients. Well, our manganese are balanced right now. We have one manganese on both sides, and irons are already balanced. There's one iron and one iron. So now move to your next step, oxygens. There's 4 oxygens on this side and none on this side. So that means we're going to add waters to balance our oxygens. So we're going to say to get 4 oxygens, we're going to have 4 waters. So 4 water molecules. Next, balance your hydrogens using hydrogen ions. So 4 times 2 is 8 hydrogens. So come back over here and you're going to put 8 hydrogen ions. That gives you 8 hydrogens and 8 hydrogens. Next, you're going to balance your charge using electrons. So this is the part that students usually mess up on the most often. So let me show you exactly how to figure out your charge. You have to make sure at this point that you're taking the coefficient times any charge you see. So 8 times 1 is a plus 8. 1 times negative 1 is a minus 1. And that's all on this side. So let's get the total. So on this side, we have a plus 7. I'm going to circle that. Net plus 7 on this side. We have 1 times plus 2 gives you a plus 2. And we have a 0. So on this side, the overall net charge is a plus 2. So now we have to make sure our charge is balanced. So I have a plus 7 on this side and a plus 2 on this side. Now you always add the electrons to the most positive side, which is this side. So if I add 5 electrons to this side, that will give me a negative 5. And a negative 5 and a plus 7 is a plus 2 net. So now I have a plus 2 charge on both sides. So let's go through those same steps for the other half reaction. Okay, the ions are balanced. There are no oxygens, so we don't need to worry about that. There are no hydrogens, so we skip that. Now the next thing we do is charge. This charge has a 1 times a positive 2 is a plus 2 charge. This is 1 times plus 3 is a plus 3 charge. This is our most positive side, so we're going to add 1 electron. And that's going to give me an overall on this side plus 2 now. And so plus 2 is equal. So now we're ready to get ready to start adding these back together. But before you add them together, you have to remember those electrons have to cancel. They cannot show up in your overall final answer. So this has 5 electrons and this has 1. So in order to get my electrons to cancel, I'm going to multiply this entire half reaction by 5. So that's going to give me 5 iron 2s, 5 iron 3s, and 5 electrons. So now let's cancel identical species. These 5 electrons cancel with these 5 electrons. None of my waters cancel and none of my hydrogens cancel. So that means you're going to bring down what remains. So let's start here. I always go left to right, top to bottom. So 8 hydrogen ions plus 1 MnO4 ion plus 5 iron 2s yields 1 manganese plus 2 ion plus 4 waters plus 5 iron 3s. So this is going to be your balanced redox reaction. Now let's take a look and check to make sure the charge as well as the atoms are balanced. So let's do the atoms first. 8 times 1 is 8 hydrogens. On this side, 4 times 2 is 8 hydrogens. I have 1 manganese, 1 manganese, 4 oxygens, 4 oxygens, 5 irons, 5 irons. So all the atoms are equal. Now let's look at our charge. 8 times 1 is a plus 8. 1 times negative 1 is a minus 1. 5 times 2 is a plus 10. So on this side here, we've got a total of 18 minus 1 is plus 17. So that means on this side, if I've done it correctly, it should be a plus 17 as well. So let's check that and see. 1 times 2 is a plus 2. 4 times 0 is 0. 5 times 3 is 15. 2 plus 15 is 17. So that is checking out on the charge. Atoms check out, so the equation is balanced. Let's look at the second example. Now this one is a little more complicated, but don't let it intimidate you. So you're going to have 2 half reactions. So this has chromium in it, and on this side there's chromium. So this is going to be one of our half reactions. This has carbon in it, and this has carbon in it. So this is going to be our other half reaction. Notice the hydrogens and the waters we kind of ignore, but keep in mind we add those back in anyway, so they're going to come back into the picture during the balancing. So let's do our half reactions. Cr2O7, 2 minus, yields Cr3 plus, and then C2H5OH yields CO2. So that's separating into my two half reactions. Now, the next step says to balance everything except for your hydrogens and oxygens with coefficients. So I have two chromiums here, so I'm going to put a 2. That gives me two chromiums on each side. I've got one carbon here, two carbons here and one carbon here, so I'm going to put a coefficient of 2 here to give me 2 carbons there. So that balances my carbons and my chromiums. So now let's balance the oxygens. So I have 7 oxygens here. Now remember, you balance your oxygens by adding water molecules. So I have 7 oxygens, so I'm going to say plus 7 water molecules. Now let's balance our hydrogens. There's no hydrogens on this side, but there's 14 hydrogens on this side. So bounce back over here, and we're going to put 14 hydrogen ions here. That's going to give me 14 hydrogens and 14 hydrogens. Now let's look at our charge. So we have 14 times 1 is a plus 14. 1 times negative 2 is a negative 2. So on this side, the net charge is plus 12. All right. 2 times 3 is a plus 6, and this is neutral. So we have a plus 6 on this side and a plus 12 on this side. Now remember, we always add electrons to the most positive side, which is over here. So I need it to be equal, I need this side to equal plus 6 because this is plus 6. So if I add 6 electrons, that's going to give me a plus 6 on this side and a plus 6 on that side. All right, so let's go through those little steps for the second half reaction. We've already done the carbon balancing, so let's go to the oxygen balancing. All right, so we have 4 oxygens here. 2 times 2 is 4, and I have 1 oxygen here. So I have 4 oxygens and 1 oxygen, so I'm going to add my waters over here, and I only need to add 3 waters because that's going to give me 3 plus that one gives me 4 oxygens. So now my oxygens are balanced. Now let's balance our hydrogens. Now be careful because there's hydrogens in both molecules. 3 times 2 is 6, and then I have 5 and 1 is 6 more. That's 12 hydrogens on this side. So we're going to add 12 hydrogen ions to this side. That balances your hydrogens. Let's do your charge last. So this is neutral. This is neutral. So on this side, there's an overall net charge of 0. This is neutral. This is a plus 12. So remember, you always add electrons to the most positive side. I need to add 12 electrons to this side. That's going to balance my charge in the second half reaction. Now, before I add these back together, remember, you've got to make sure all the electrons cancel. So I have 12 electrons here and 6 electrons here. The only way to get all the electrons to cancel is to multiply this top half reaction by 2. So we're going to multiply this whole thing by 2. So I'm going to go ahead and write it down so I don't forget to distribute it throughout. This one's going to give me 12 electrons. This is going to give me 28 hydrogens. This is going to give me 2 dichromates. This is going to give me 4 chromiums, 3s. And this is going to give me 14 water molecules. Now, cancel out the identical species. So these 12 electrons cancel with these 12 electrons. Remember, they have to cancel. Now, in this half reaction or this redox reaction, I have other things that will cancel. Notice, I have 28 hydrogens here and 12 hydrogens here. That means all 12 of these will cancel out. So 28 minus 12 is going to give me 16 hydrogens on this side left over. Okay? Now, the waters. I have 14 waters here, 3 waters here. So all 3 of these waters are going to cancel, and that's going to leave me with 11 waters on this side. Nothing else cancels, so let's bring down everything that hasn't canceled. So let's start here. I go top to bottom, left to right. So we have 16 hydrogen ions plus 2 dichromate ions plus 1 C2H5OH yields 4 chromium 3 ions plus 11 water molecules plus 2 carbon dioxides. So this is your balanced redox reaction. Now let's check just to make sure everything is equaling out. Atoms, 16 hydrogens plus 6 more gives me 22 hydrogens, and 11 times 2 is 22. 4 chromiums, 4 chromiums. 14 oxygens plus this one gives me 15 oxygens. So that gives me 11 plus these 4 give me 15 oxygens, 2 carbons, 2 carbons. So the atoms cancel. And now let's look at our charge. 16 times 1 is a plus 16. 2 times negative 2 is a negative 4. And this is neutral. So on this side, the net charge is positive 12. So that means on this side, it has to be a positive 12. So let's check it out and see. 4 times 3 is plus 12. That is 0, and that is 0 because they're neutral. So the charges cancel as well. So that is how you balance the redox reaction. Now in the next video, you will have some more that I go through with you on the balance and redox reactions worksheet.